2 for graphing rational functions. So first thing I want to do is let's draw our graph here. Okay, so if I can find domain, my asymptotes, my intercepts, all I really need at that point is just a few other points by plugging in x values, and we should be able to sketch a pretty reliable graph here. So let's see, domain. For domain, we know that I cannot have 0 on the denominator, so I'm going to have restricted values when x is equal to -1. So domain, I'll have from -infinity to -1, and -1 to +infinity. So that restricted value is actually going to serve as our vertical asymptote. So that's the first thing that I would sketch. All right, so our horizontal asymptotes, we talked yesterday that the horizontal asymptotes, what you need to do is compare the power of, or the degree of your numerator to the degree of your denominator. So I have a degree of 1 on both. So what we do is then we look at the leading coefficient for the numerator and the denominator. So that the ratio of the leading coefficients is actually going to give us the equation for our horizontal asymptote. So y equals 2 will be a horizontal asymptote. Okay. Next thing, we'll find some x-intercepts. X-intercepts means y, and I know my numerator will have to be 0. Which will give me an x-intercept of -3, 0. Okay, so y-intercept, I would plug in 0 for x, which is just going to give me 6/1, which is 6, meaning I have a y-intercept at 0, 6. The last thing you want to do is let's find a few other points. So if you have a vertical asymptote, let's plug in a couple x values to the right to find where the points would be, and then let's plug in a few to the left of that vertical asymptote. So let's start with the right. I have when x is 0. Let's try when x is 1. So we'll say other points, and we'll say f of 1 equals 2 times 1 plus 6/1 plus 1. So I see that I have a point at 1, 4. Let's try plugging in 3, get one more point to the right. And we get 3, 3. So these asymptotes are going to act as a guide. So I know that I'm going to follow the asymptote out to the right, and I'll follow this one up towards +infinity. So now let's find a point to the left of this asymptote. So let's plug in, this is -1. Let's plug in -2. Which gives me -2, -2. And then let's go just to the left of this x-intercept. So let's plug in Let's try -4. And we get 2/3. So again, because I have to kind of follow these asymptotes as guides, I can kind of fill in. So you can check this on Desmos or on your graphing calculator just to verify. But we know I'm not going to have any points in this section down here to the lower, like this lower right quadrant or the upper left, because if I did, for example, if I had another section of graph here, this would no longer pass the vertical line test, and therefore it would not even be a function. Okay, so just using what we know about functions, I know that this is pretty much the entirety of the graph. Number 2, so things will be a lot easier if you factor everything from the beginning. So if I factor the numerator, I get x minus 4, x minus 1, and then denominator x plus 2, x minus 2. So this is going to help me quite a bit when I'm plugging in points later. I don't have to worry about squaring anything. Just going to make things a little simpler. So domain, let's see, negative infinity, -2, -2 to 2, and then 2 to infinity. So I'm going to have vertical asymptotes at x equals -2 and x equals +2. Okay, we'll see I have a power of 2 on the top and bottom, meaning I look at my leading coefficients again for my vertical asymptotes, and I get 1/1, which would just give me y equals 1. X-intercept, let's plug in 0 for y. And I get 4 and 1 as my two x-intercepts. And then for my y-intercepts, when I plug in, I get -4 times -1, which is 4, over -4, which is -1. So 0, -1 for a y-intercept. Other points, let's work on this vertical asymptote first. I want to find some points to the right and to the left. So if I look to the right, let's find f of 3. And this is where it's easier just to plug into my factored form, at least in my opinion. So I get negative 2/5. So you can kind of tell connecting these and knowing I need to follow the asymptotes, it's going to go out to the right, and then this will head downwards. Let's check in the middle here. So let's check. I already have a few points, which helps me a little bit. One thing that I do know is that since this is my only x-intercept, if I'm connecting from this point 0, -1 going left, I know that I can't head upwards and go to positive infinity because that would cause me to create another x-intercept that's not actually there. So that tells me I have to head downwards from this y-intercept. Now the question is, once I hit this x-intercept, am I going to go, excuse me, am I going to go up towards positive infinity because I am allowed to cross this horizontal asymptote, or am I going to turn downwards and go towards negative infinity? So what I want to do is, let's plug in a point in the middle here, 1.5 maybe, and I'm going to plug that into my factored form as well. And the kind of nice thing about this is that I don't really need to know the exact coordinates at that point. I just need to know if it's positive or negative. If this spits out a positive y value, I will head to positive infinity. If it spits out a negative y value, I'm going to head towards negative infinity. So let's see. This is going to give me a negative number times a positive number, which will be negative something on the top. On the bottom, this will give me a positive number. This will give me a negative. Positive times negative is another negative. So if I have a negative number on top and a negative number on the bottom, that's going to equal a positive number. So I don't even really need to know what the coordinates are. I know that when x is 1.5, I'm going to have a positive y value. So somewhere up here, which means I'm going to have to follow that asymptote to the top. Okay, last part. I want to find at least one point to the left of this x equals -2 asymptote, because I don't know if I'm going to be in this upper left or the bottom left. So let's plug in -1, 2, 3. Let's plug in -4. So that gives me 40 over what is this, -2 times -6, so that gives me positive 12, which is that like 3.33 or something like that. So when x is -4, I'm going to be up just above 3. Meaning I'll have to follow this towards the top and this out to the left. And we should be good.